Suppose if alpha and beta are the two roots, then the quadratic equation can also be represented as x minus alpha into x minus beta is equal to 0. The nature of roots, so whether it is a real root, whether it is an imaginary root, so that can be decided with the help of discriminant. If we take the quadratic equation ax square plus bx plus c, the coefficient of x square is a, the coefficient of x is b, and c is a constant. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to study about the another type of equations, quadratic equation. So quadratic equation will be in the form of ax square plus bx plus c is equal to 0. Observe here, a cannot be equal to 0 because the highest degree of the variable in the quadratic equation must be 2. So, the equations of the form ax square plus bx plus c is equal to 0 containing as the highest power as x is called as quadratic equation or a second degree equation. Since the degree of this equation is 2, it is also called as second degree equation. Now, the quadratic equation has 2 and only 2 roots. Roots are nothing but the solutions for the given equation. So, I already told you in the previous session that if a quadratic equation is of degree 2, then it will be having 2 solutions also called as roots. Now, suppose if alpha and beta are the 2 roots, then the quadratic equation can also be represented as x minus alpha into x minus beta is equal to 0. Now, form the quadratic equation whose roots are 1 and 2. So, let us consider 1 and 2 are the roots. Then we can write it in the form of x minus 1, x minus 2 is equal to 0. So, if alpha and beta are the roots of the quadratic equation, then we can represent the quadratic equation as a product of 2 linear factors. Next is we will try to solve the quadratic equation. We are already familiar with 2 types of solutions. One is by the factorization method, another is by the formula method. Now let us try to solve with the help of factorization method. So 2x square minus 7x plus 3 is equal to 0. We need to find out the solution for this equation. So here 2 3s are 6 and when you add it should be minus 7. So I'll write this in the form of 2x square minus 6x minus x plus 3 is equal to 0. I'll take 2 as a common factor and x as a common factor. Then I'll get x minus 3 minus 1 I'll take as a common factor. X minus 3 is equal to 0. So again x minus 3, if I take as a common factor, I'll get 2x minus 1 is equal to 0. So this implies x is equal to 3 and if I take 2x minus 1 is equal to 0, then I'll get x is equal to 1 by 2. So therefore, these are the solution for the given quadratic equation. Next, 4x square plus 4x minus 15. So 15 fours are 60. So when you multiply, you should get 60 and when you take a sum or difference, you should get it as 4. We know that 60 can also be written as 10 6s. So here, I'll write this in the form of 4x square plus 10x minus 6x minus 15 is equal to 0. I'll take, since these two are even numbers, 2 as a common factor and x as a common factor. Then I'll get this as 2x plus 5. Now again I'll take 3 as a common factor. Then I can write this as 2x plus 5 is equal to 0. So I'll get 2 linear equation, that is 2x plus 5. And 2x minus 3 is equal to 0. If I equate them to 0, here I'll get x is equal to minus 5 by 2 and here I'll get x is equal to 3 by 2. So these two are the roots of the given equation. Next, we'll solve the quadratic equation using the formula method. What is the formula we have learnt previously? We have learnt x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. So this is the formula which is used to solve the roots of a quadratic equation. So now here the question is given in the form of 3x square minus 13x plus 12 is equal to 0. Generally we always represent quadratic equation as ax square plus bx plus c is equal to 0. Now using that formula, so we can find the value x is equal to minus b. Here it is already minus. So minus of minus 13 plus or minus square root of b square is nothing but minus 13 whole square minus 4 into a into c, that is 3 into 12 under the square root whole divided by 2 into value of a is 3. Now here it is 13 plus or minus, so 169 minus 12 3s are 36. So again we'll get it as 44. So now 6. So if you solve this, you will get this as 13 plus or minus root 25. So root 25 can be written as 5. So we will get the answer as 5 by 6. So now we can take x is equal to 13 plus 5 by 6 and x is equal to 13 minus 5 by 6. Therefore, x is equal to 15 by 6 is 3 and here 13 minus 5 is 8. So 8 by 6 can be written as 4 by 3. So these two forms the roots of the quadratic equation. Next, x square plus 6x plus 8 is equal to 0. So x is equal to minus b, which is minus 6 plus or minus square root of b square, 6 square 36 minus 4ac, 4 into a into c, so that is 32 divided by 2 into 1 is 2. So we have minus 6 plus or minus 36 minus 32 is root 4 is 2 divided by 2. So x can be taken as minus 6 plus 2 by 2 and x is equal to minus 6 minus 2 by 2. So therefore, x will be equal to minus 4 by 2 minus 2 or x is equal to minus 8 by 2, which is minus 4. So until now we have found the solutions or found the roots of the quadratic equation. Now we'll discuss about the nature of roots. So the nature of roots of ax square plus bx plus c is equal to 0. The quantity b square minus 4ac on which the nature of roots is depend is called the discriminant. So the nature of roots, so whether it is a real root, whether it is an imaginary root, so that can be decided with the help of discriminant. Now here, if b square minus 4ac is equal to 0, then we say that roots are real and equal. So if the discriminant value is 0, then we say the roots are real and equal. That means you will get two roots which is having the same value. Next, if b square minus 4ac is positive, when I say positive, this value must be greater than 0. Then the roots are real and unequal. That means the roots are real numbers and there are two different roots. For example, x is equal to minus 2, x is equal to minus 4 are real roots and they are different here. Next, if b square minus 4ac is negative, then the two roots are unequal and imaginary. So if the value of b square minus 4ac is negative, then under the square root, we will have a negative real number. So which cannot be a real root, which is called as an imaginary root, and they are also unequal. Find the nature of roots without solving the equation. So without finding the solutions, we are supposed to tell what is the nature of the root. Now here we need the value of b square minus 4ac. So b square is 36 minus 4ac, 4 into 2 into 3. So 4 2s are 8, 8 3s are 24. So we have here 12, which is greater than 0. So therefore, they are real and unequal. We also call it as distinct. Next, x square minus x plus 1. So let's check b square minus 4ac. So minus 1 whole square minus 4 into 1 into 1. So which is 4. So minus 5. Minus 5 is a less than 0, which is a negative number. So here they are, that is this discriminant value is less than 0. Therefore, roots are unequal and imaginary. Next, 36x square minus 12x plus 1 is equal to 0. So b square minus 4ac. 12 square 144. 36 into 4 into 1 144. So it is 0. So therefore here roots are real and equal. This b square minus 4ac sometimes can be written in the form of d. Sometimes it can be written in the form of delta also. We can also use delta symbol to denote discriminant. So thus, if discriminant is equal to 0, the roots are real and equal. Discriminant is positive, roots are real and unequal. Discriminant is negative, roots are imaginary and unequal. Next, we will study the relation between the roots and the coefficients of the quadratic equation. Now, if we take the quadratic equation ax square plus bx plus c, the coefficient of x square is a, the coefficient of x is b and c is a constant. And if we take alpha and beta are the roots of the quadratic equation, so we have a relation between the roots as well as the coefficient. That is the sum of the roots. Alpha plus beta can be written as minus b by a. So what is minus b? It is the coefficient of x and a is the coefficient of x square. And the product of roots can be written as c by a, where c is a constant and a is a coefficient of x square. So thus alpha plus beta, sum of roots can be written as minus b by a and product of the root can be written as c by a. So what is the use of writing the sum of and the product of root? So generally, by knowing the sum of roots and product of roots, we can also write the quadratic equation as x square minus alpha plus beta into x plus alpha beta is equal to 0. So this also forms the quadratic equation. If alpha and beta are the roots of the equation, 2x square plus 4x plus 1 is equal to 0, find the value of alpha square beta plus beta square alpha, alpha to the power minus 2 plus beta to the power minus 2, alpha square by beta plus beta square by alpha. So let us solve them one by one. Before that, let us find what is alpha plus beta. Alpha plus beta is minus b by a. So this is a, this is b and this is c. So minus b by a means minus 4 by 2, which is equal to minus 2. Next we will find out alpha beta, which is c by a. So c value is 1, a value is 2, so 1 by 2. Now let me take the first question. Alpha square beta plus beta square alpha. So in both the term we have alpha and beta as a common factor. So I'll remove alpha and beta. So then I'm left with alpha and here in the second term beta. So alpha beta is 1 by 2. Alpha plus beta is minus 2. So when we cancel, we'll get the value as minus 1. Next we have alpha to the power minus 2 plus beta to the power minus 2. That can be written as 1 by alpha square plus 1 by beta square. So which can also be written as alpha square plus beta square divided by alpha square beta square. Now I need to express this in the two form using alpha plus beta and alpha beta. So we know that a plus b whole square is equal to a square plus b square plus 2ab. If we want a plus b whole square, then we'll subtract minus 2ab from a plus b whole square. So therefore this can be written as alpha plus beta whole square minus 2 alpha beta. Denominator can be written as alpha beta whole square. Now since I know the value of all these, this is minus 2 whole square minus 2 into 1 by 2 whole divided by 1 by 2 whole square. So if you solve this, this is 4 minus 1 divided by 1 by 4. 4 minus 1 is 3. 1 by 4 we need to take the reciprocal. So the value will be equal to 12. Next we have alpha square by beta plus beta square by alpha. Alpha square by beta plus beta square by alpha. So which can be written as alpha cube plus beta cube divided by alpha beta. Again using the identities of algebra, This can be written as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta whole divided by alpha beta. So here we'll get minus 2 whole cube minus 3 into 1 by 2 minus 2 divided by 1 by 2. So this is minus 8 and here 2 get cancelled. 3 ones are 3, minus into minus plus 3 divided by 1 by 2. So minus 8 plus 3 is minus 5 and divided by 1 by 2, when we take the reciprocal, it is multiplied 2. So minus 10 is the answer. Next one. If alpha and beta are the roots of the equation 2x square plus 5x plus 5 is equal to 0, find the value of 1 by alpha plus 1 by beta, 1 by alpha square plus 1 by beta square, alpha by beta plus beta by alpha. So this is A, B and C. So now let's find what is alpha plus beta. So that is B by A minus B by A. So minus 5 by 2. Now let's check alpha beta. So which is C by A, which is 5 by 2 again. Now first one, 1 by alpha plus 1 by beta, which can be written as alpha plus beta by alpha beta. So which is minus 5 by 2 divided by 5 by 2 cancels, the value is minus 1. And 1 by alpha square plus 1 by beta square can be written as alpha square plus beta square by alpha square beta square. So using algebraic identities, this can be written as alpha plus beta whole square minus 2 alpha beta and denominator can be written as alpha beta whole square. Now alpha plus beta is 5 by 2 whole square minus 2 into 5 by 2 divided by 5 by 2 whole square. So this is 25 by 4, 2 get cancels, minus 5 and here again 25 by 4. Now this is 25 minus 20, so 5 by 4 divided by 25 by 4, 4 get cancels, 5 ones are 5 5s are, the value is 1 by 5. Next we have alpha by beta plus beta by alpha, so which is again alpha square plus beta square by alpha beta. So which can be written as alpha plus beta whole square minus 2 alpha beta whole divided by alpha beta. Now minus 5 by 2 whole square, 2 into 5 by 2 divided by 5 by 2. So 25 by 4 minus 5 whole divided by 5 by 2. So now here 25 minus 20, so we will get 5 by 4 whole divided by 5 by 2. 5 get cancelled, 2 ones are 2 2s are, so the value is 1 by 2. So just by using the relationship between the alpha plus beta and alpha beta, we can evaluate many problems using the roots of the quadratic equation. So in this session, you have learnt about the quadratic equation. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.